Hello. Give me some sunshine, give me some rain, give me another chance. I wanna grow up once again. Na 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 na. We have 3 more minutes, okay? 2 more minutes. Na 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 na. Good morning, everyone. Na 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 na. Na 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 na. Na 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 na. 1 minute to go. Na 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 na. Give me some sunshine. Give me some rain. Give me another chance. I wanna grow up once again. 30 seconds. Have you ever noticed me coming late to a class? Only problem is if I have back-to-back classes, I will take 5 minutes to reach. I will always be before time for any class. Why? I love teaching. When you do what you love, it doesn't feel like work. Find a work which you love and make someone pay for it, and you will become great in your life. Remember this. What simple formula? Find a work which you love and make someone pay for it. Okay. Okay, guys, time is 9 o'clock. Let's start. Let's have fun. Okay. The fun begins now. Na, 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 na. Na, 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 na. So I'll give you a question, you tell me the answer. Please join the Telegram channel, everyone. Okay. How many ways can 7 girls be seated at a round table so that 2 particular girls are separated? 2 particular girls are separated. Answer this. All of you open Telegram channel and answer in the Telegram. Or you can also, let's do on YouTube only. Okay. Answer in YouTube. It is just numbers, right? You don't have to write anything. Answer in YouTube. What is the answer for this? Na, 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 na. Na, 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 na. Na, 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 na. This kind of problem we solved in the class, right? What is the answer? Why no one is able to answer it? It should take seconds here. This is all common sense. Tell me the final number, okay? I have given you options also, A, B, C, D, E. Tell me the final answer. Gnana, very good, Gnana. Gnana, very good, Gnana. Everyone should answer it. Only one person has answered. What's this? What's happening? Darshanam. Okay. Okay, see this, I'll explain. Okay. 7 girls are to be treated in the, okay, let us say there are 7 girls. Okay. Let us say there are 7 girls. G1, G2, G3, G4, G5, G6 and G7. Okay, now what is the question? Two girls should always be separated when they are seated in a round table. Okay, you cannot directly solve it, right? The reason is you will get many cases, right? Between the two girls, there can be one girl, there can be two girls, there can be three girls, like that you will get a lot of cases. Now instead of that, you use complementary method. Now what is the complementary method? Take all possible arrangements of 7 girls around a table and subtract from it by putting two girls are always together, right? So how are we going to solve it? See this. Two girls have to be always together, right? Two girls always together. Always not together or separated. Two girls always separated, right? Now how can you write it? Total. Take total arrangements minus two girls are always together. Okay. Two girls are together, always together, right? Now what is the total? 1, 2, 3, 4, 5, 6, 7. When you put in a circular arrangement, I told you that it is n minus 1 factorial. We discussed it in the class here. I don't know why you are not able to answer it. Okay. If you are not able to answer it, please drop gate. You are not fit for gate. If you are not able to answer this, please drop it. Okay. Don't prepare for gate. You will not get a rank. Okay. After explaining so much in the class, after solving hundreds of problems in the class, you are not able to answer a simple question. How do you expect to clear gate? You didn't revise the notes. Just forget it. Simple question. What is there in it? 6 factorial. Number of n of u. Now make two girls together. Glue them together. Just glue them together. Now how many objects are there in total? 1, 2, 3, 4, 5, 6. Right? You have to place these 6 objects in a round table. Therefore, it is going to be 5 factorial into, you can jumble them, right? You can change G1 and G2, you can jumble them in 2 factorial ways. So the answer is going to be D480. D480. Okay? Answer this question. A team of 11 is to be selected out of 14 people, out of which 5 are bowlers. Find the number of ways in which this can be done as to include at least 4 bowlers. At least 4 bowlers should be included. At least 4 bowlers should be included. We solved this model also in the class. We have taken many questions in this model. Hypergeometric distribution. పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పెట్టుకున్నవన్నీ నువ్వు కట్టుకపోతావారా, పోరి పోరి అంటో దాన్ని చుట్టుకుంటావారా, సక్కపోసి పెగ్గేస్తా ఆ ఆ ఆ ఆ. రైట్? అన్నంత ఓకేయా? పోతా పోతా. Okay, answer this question. We have solved such models in the class. Why are you taking a lot of time? I don't understand. Common sense. What is CS, guys? It is not computer science, it is common sense. I made it so clear in the class that it is common sense. These are all common sense questions, right? Very good. The answer is 264, A264, right? So what is their simple question? There are 14 players, okay? Out of which you have to choose 11 players. Draw the hypergeometric distribution, right? Now what are they saying? There are 5 bowlers, okay? So out of this, there are 5 bowlers and 5 bowlers, right? Of whom 5 are bowlers, right? 5 bowlers, 5 bowlers, and then we have 9 non-bowlers. Don't write batsmen, write non-bowlers, because there can be wicket keeper also, right? It is better to write non-bowlers. 5 non-bowlers, right? Now what should you do? You should pick the team in such a way that there are at least 4 bowlers. There are at least 4 bowlers, right? So what do I mean? I can pick 4 bowlers, right? And then we need to make 11, right? So I can pick 7 non-bowlers, or I can pick 5 bowlers. I can pick 5 bowlers and 6 non-bowlers. Now at least 4 is 4 and 5 only. You cannot go for 6. There is no 6 here. Only 5 bowlers are there. Only 2 cases you get, right? Now what are these 2 cases? So from 5 bowlers choose 4 bowlers. 5C4 into, from 9 non-bowlers you choose 7 non-bowlers. 9C7 plus 5C5 into 9C6. 5C5 into 9C6, right? Right? Okay. Answer this question. How many odd numbers have 4? How many odd numbers having 4 digits and with no repeated digits can be formed from 1 to 9? From 1 to 9, how many odd numbers can you form? And there is no repetition. There are only 9 numbers. You have to observe that there is no 0. 1 to 9 are 9 numbers. 1 to 9 are 9 numbers, right? 1 to 9 are 9 numbers. All of you answer in the YouTube, okay? All of you answer in the YouTube. Okay? Okay? All of you answer in the YouTube. Very good. You have answered it. So the answer is B, 1680. See, we want what? 4-digit numbers, okay? Go by box method. Remember this, whenever there are constraints given, you have to use the box method. Don't use the formula directly. Actually, this is without repetitions and permutation. So what is the category? NPR is the category that we discussed in the class. But even in NPR, when the constraints are given, always go by the box method. I told you in the class, right? Very few people are able to answer this. If you are not able to answer this, please drop gate, okay? Please drop now. Don't waste your time. It is just a waste of your time. 100% efforts give you 100% results. 50% efforts will give you 0% results, not 50% results, right? If you are dedicated to crack gate, give your best, give your 100%. Whatever you choose in life, give your 100%. And now you have come too far to go back. At least from now, give your 100%, okay? Fine. What is the answer? 1680, right? Simple question. There are 1 to 9 digits, right? And you want to make a odd number. Now, if I want to make a odd number, how many choices are here? It can be end with 1, end with 3, end with 5, end with 7, end with 9, right? So I have 5 possibilities, okay? Now one number is gone here. How many possibilities will I have here? Out of 9, one number is gone. You cannot repeat it. Therefore, you have 8. Now out of 9, 2 numbers are gone. So you have 7 choices. And out of 9, 3 numbers are gone. You have 6 choices. Now it is coming to B 1680. B 1680. Right? Right? Answer this question. The mth term of an AP is n and nth term of the AP is m. The m plus nth term would be, this is 10th class question. It is not even gate level. It is not even my level, or it is not even your level. It is 10th class question. I have intentionally added 5 options to confuse you. Okay. There were only 4 options. I have added 5 options just to confuse you. Okay. This is 10th class math, right? Mth term. So they are saying that mth term is equal to n and nth term equal to m. Try it. Try this. Sir, I have started DBMS lectures of 2024 recorded and half classes completed. Should I continue with that or start with the present ultimate DBMS? Yeah, start with the ultimate DBMS course, Anant. Okay. All of you, whenever our live classes are going on, don't watch the recorded classes, watch live classes, because live will always be fun, right? Live will always be fun. You will see the fun, you will feel it. Cool. So it is 0. I'm not going to solve it. It is a 10th class question. This is not my range. Okay. Fine. Now, nth series of a given nth series is nth term of a series is 3n plus 1. Find the sum of first 105 terms in this series. Again, this is a series they have given, right? Right. Find sum of 105 numbers. Find sum of 105 numbers. Find sum of 105 numbers. So you have to find sum of 105 terms of this series. Find the sum. So there is one line, one word missing. Find the sum of first 105. Find the sum of first 105 terms of this series. Try it. Try it. It is also a 10th class question. I will explain it still, but that is not my range. This question is not of my range. Give me some sunshine, give me some rain, give me another chance. I wanna grow up once again. What is the answer you got? Very good. You are going to get C1470, right? So they are saying that nth term is 3 plus n by 4. 3 plus n by 4. That is what they are saying, right? Now, what is sum of n numbers? Sum of n numbers equal to sigma n equal to 1 to n. Sigma n equal to 1 to n. Tn. Sum of n terms is Tn. Now you just substitute Tn in this place. What is that you are going to get? Sigma. This is 10th class math here. 3 by 4. So this is 3 by 4 plus n by 4. I will write like this. 3 by 4 plus n by 4, right? Mathematics and 10th class, it is very simple. So you are going to get 3 by 4 into sigma n equal to 1 to n 1 plus sigma n equal to 1 to n. I will write 1 by 4 outside and I will write n here. Now what is n equal to 1 to n sigma 1? This is nothing but n, right? So 3 by 4 into this is nothing but n. Now what is the sum of first n natural numbers? Sum of first n natural numbers is n into n plus 1 by 2, right? Now in place of S, what do we want? 105. Substitute 105 in place of N and you are going to get C as the answer. 10th class maths, okay? If you are not able to solve it, leave gate, okay? I am brutally honest and I don't sugarcoat, right? I don't care, okay? I will just be brutally honest. You know about me, right? I will not try to be nice. I will not try to please anyone, okay? If you like it, love me or hate me, you cannot ignore me, okay? Fine, answer this question. Next question. Take time and answer it, okay? We have solved this in the class, right? We have solved it in the class. You are taking so much time. After solving hundreds of questions in the class, you are taking so much time. Okay, take time. That's okay. But answer me. Give me the correct answer. Okay. Maybe you have not practiced questions or you didn't revise the notes. Just take time and answer it. Hypergeometric distribution. This model we have solved hundreds of questions. Hypergeometric distribution, right? Hypergeometric distribution. I told you how to handle two constraints. Very good. Answer is D, 780. Right? Don't write the questions. I will give you this PDF. For those who are registered for the course, I will give you all the PYQs ka PDF. Don't write the notes, okay? Okay. So, what is it? A candidate requires to answer 7 out of 12 questions. Okay. Total number of questions are 12. Total number of questions are 12. Okay. And then they are saying that it is divided into two groups of 6 each, which means 6 questions are here and 6 questions are here, right? And he has to answer 7 questions. Okay. He has to answer 7 questions. Now, he is not permitted to attempt more than 5 questions from each group. From each group, he cannot attempt more than 5 questions, right? So, which means from each group, he is not permitted to attempt more than 5 questions, which means this is less than or equal to 5 and this is also less than or equal to 5. So, he can go till 5, but he cannot go beyond 5. He is not permitted to attempt more than means 5 is allowed, 6 and 7 are not allowed. So there are two constraints. Now I told you in the class how to handle two constraints. How do you handle two constraints? Simple. Take one constraint, write down all the cases and then remove the cases for in which the second constraint is not valid. Okay. So we have to get 5 and 5. So I will start with 0, right? So 0 questions from one group. 0 questions from one group. Then how many questions should I take from other group? 7 questions, right? Now 1 question, 6. 2 questions, 5. 3 questions. Okay, so let me write it here. So you can take 0, 7, 1, 6, 2, 5, 3, 4, and then 4, 3, 5, 5 and then 2, right? So these are all the cases possible. These are all the cases possible. Now, you cannot go for 6 here. The reason is you cannot go beyond 6, beyond 5. And here also you cannot go beyond 5. It is going till 7. See, you are satisfying the condition for first group. Now you have satisfied the condition for first group. Now out of these cases, this case is not valid because 5 and 7 is greater than 5. This case is not valid because 6 is greater than 5. Now how many cases you have? 1, 2, 3, 4. Now you just write 6C2 into 6C5 plus 6C3 into 6C4 plus 6C4 into 6C3 plus 6C5 into 6C2, right? You can write all these cases and you are going to get the answer as 780. We have solved such models, right? Lot of questions I did in hypergeometric distribution. Even with inclusion exclusion, I have done it, right? Okay. Answer this question. Again, this is a 10th class question. Okay. There are 2-3 questions of my range. That's it. This is what? Rule of sum and rule of product. Rule of sum and rule of product. Why are you taking so much time? This is rule of sum and rule of product, right? Nah, 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 nah. Only one person has answered it. Obviously 6. I'm not going to do it, okay? This is not of my range. Next. This is also a kind of 10th class question. Answer this. Give me some sunshine. Give me some rain. Very good. Very good. So what are they saying? A lock contains 3 rings. Okay, a lock has 3 rings. 1, 2, 3 rings, right? And each ring has 4 letters. Each ring contains 4 letters, right? So let us say A, B, C, D, A, B, C, D, and A, B, C, D. Okay. Now, if the lock opens in only one arrangement of these letters, how many unsuccessful events are there? See, totally how many are there? 4 into 4 into 4, and out of which only one is correct one. So, how many wrong ones will be there? 4 into 4 into 4 minus 1, which is B63, right? B63. Answer this question. We have solved this question. If anyone answers it wrong, I will see, okay? We have solved many questions in this model. We have solved hundreds of questions in the class. You miss some rain. ఏంది కబుర్లు? Good morning, Bunny. Oh, it's Mother's Day, na? Happy Mother's Day, ma. तुझे मिलके लगा है ये. Okay, so we have 7 factor. Should I solve it? This is not my range. Okay, so if you want me to solve it, I'll solve. See, there are 8 boys, right? Now, how many ways can you make 8 boys sit in a round table? There are 7 factorial ways, which means 8 minus 1 factorial, right? Now, if 8 boys are sitting, how many gaps do you get? 8 gaps. So, if 2 boys are sitting, we got 2 gaps, right? Here is a place, here is a place. If 8 boys sit, there will be 8 gaps. Now, it is a permutation question because once there are fixed boys, I told you in the class it is a permutation question, right? So 8p, how many girls should be placed? 6, so that they will not sit together. Okay. Answer this question. In how many ways I differentials can be distributed among 4 different people so that each receives 2 sheds? So that each receives 2 sheds. We solved this model also in the class. We solved this model also in the class. Is it worth to take course as you are explaining everything on YouTube? Yeah, PYQs will be on YouTube. All the classes will be on for the paid people. Is it worth? So this question is interesting. Someone is asking, is it worth to take course? Understand one thing, it is a privilege to learn from me. Okay? Yeah. You may feel that I'm overconfident, but you should always be so confident that others should think that you are overconfident. Your confidence level should be that high that people should think that you are overconfident. Okay? तुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं. Everyone got, what is the answer you are getting, guys? C, right? 2520. C is 2520. Right. So what is the question? Distinct to distinct, right? So there are 8 different shirts and it has to be divided to people. People are always distinct, right? So this is a distinct to distinct question and this is ordered partitioning which we have discussed in the class. Ordered partitioning. Ordered partitioning, right? I am your friend, I am your brother. So you are I'm not of your generation, okay? You are all Gen Z kids. You cannot treat me like a friend, but you can treat me like a brother, okay? Yeah, I'm friend, I'm mentor, anything. Okay, this is ordered partitioning, right? So what is it? 8 factorial divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial, right? So you get 2520, 2520, right? So the sum of first n natural numbers is this, then the nth term is. I'm not going to do this, okay? You do it and tell me the answer, okay? You do it and tell me the answer, okay? तुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं, तुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं, तुझ में है कुछ ऐसी सा, मैं तो जगा सा. Very good. So the answer is E, 4n plus 1. How do we get it? See, when the sum is given, when the sum, what is Tth? The nth term is nothing but from, you take sum of n numbers and from that you subtract the sum of n minus 1 numbers and then you are going to get the nth term. So what is it? What is sum of n numbers? 2 into n square plus 3n. That is already given, right? The sum of first n terms. See, this word is very important, okay? This word is very important. They may twist it saying sum of the numbers from fourth term to nth term. There, that is a different model. That will be very difficult to solve. They will not ask you, but then always see that first is given, okay? Now Sn minus Sn minus 1. Now what is Sn minus 1, guys? 2 into n minus 1 whole square plus 3 into n minus 1. Now if you just simplify it, you are going to get 4n plus 1. Please do that simplification, okay? Answer this. Mahi, 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 तू ही तो तमन्ना What is the answer, guys? What is the answer you got? D18. D18. Right, in a football championship, 153 were played. 150 match. See, if how many ways can all the teams play with each other? From n teams, you have to choose two teams, right? So you can write like this: nc2 equal to 153. N into n minus 1 is equal to 153 into 2. See, don't write the quadratic equation and don't try to solve it. Whenever such a equation is given, just use the options and eliminate the options and choose the correct option. Use calci and see which one is matching with this number. That's it, okay? Don't solve the quadratic equation. It will unnecessarily waste your time. In GATE, every minute is a mark, okay? And every mark is thousands of ranks. And every rank is either IASC or IITs or fail. If you can save even 1 minute in GATE, you can at least get 500 plus ranks. Okay, you can go up by 500 plus ranks. It is all about saving time. Life is all about saving time. Why did you pay fee to me? To save your time. I read a lot of textbooks, all the textbooks. I'm sharing the knowledge. So your time is saved. Life is all about saving time. Look at any company which is making money, they are trying to save time of others. That's it, right? That is how all the businesses work. Time is the only precious thing in the world, right? Other than time, anything you can buy, but you cannot buy time. And you will pay anyone who is willing to save your time. That's good, actually. Why should we do everything? Okay. Fine. This is a simple question, right? Solve it, solve it, solve it. Okay, no problem. Chaitran, welcome to the party. Welcome to the party, Chaitran. Chaitran is just in second year and he is doing amazing. So I am going to tell you who is going to get first rank this time. Mark my words. Chaitran is going to get single digit rank and he is my offline batch student. Mark these words, record this video and keep it with you. Chaitran is a second year student. Next year he is going to write GATE and he will get a single digit rank. Mark my words. Okay. I know who will get ranks. Welcome to the class, Chaitran. Let's rock it. A bag contains 10 white balls, 15 black balls. Two balls are drawn in succession. The probability that one of the black ball, one is black and other is. So again you do hypergeometric distribution. Okay. Again you do hypergeometric distribution. This question we have solved in the class. It is just 1 by 2. Okay. The exact same model we have solved. Again, this is a stupid question. I'm not going to. Okay, you solve it and tell me the answer. Okay, you try first read it. Okay, first read it. Anant, great Anant. If you want to get a single digit rank, come to my offline batch. And you are welcome. You are welcome, Anant. Where are you from, Anant? Anant, why don't you come to Hyderabad? I will give a letter to your college saying that I will take permission from your college. Just leave college, come to the offline batch. Let's rock it. You please WhatsApp me on the business number. You are welcome to my class, offline class. Weekends study room. This study room is for every day. So weekends are not going to be sufficient. We have just 9 months and we have to cover a lot of syllabus, right? So weekend batches are not possible. Okay. This is going to take time. Okay. Okay. So this is a simple question. Inclusion-exclusion principle. A, B, C, right? A union, B union, C. How are you going to write it? Don't write the formula. You directly, single term is plus, second two terms is minus, three terms is plus. That's it. Don't write the entire formula. Just solve it. What is the answer you are getting? 6. Okay. 10th class mathematics. This is, see, in GATE only 20% of the questions will be of high level, and the remaining questions will be very easy to solve. Yeah, inclusion exclusion principle. We have seen it in the class. Okay. What about this? We have also seen this in the class. Very good. Sridhar and Divya. Yeah, Divya is one more student from my offline class. He is going to get a single digit rank. Remember these two names for now, right? Chaitran and Divya. These people are going to be in top 10 in 2027. Divya, are you ready? Challenge accepted. And Chaitran, is the challenge accepted? Yeah, Anand, I will talk to your principal and get the permission for you. Very good, Chaitran. Very good, Divya. Isha, very good. So this is D none, right? So see, you have a binary string with n zeros and k ones. So first you arrange n zeros. If you are arranging n zeros, there is only one way, right? If you are arranging n zeros, there is only one way. Then how many gaps will be there? The number of gaps will be n plus 1. Now, out of this n plus 1, just you choose k gaps. That's it. And in those gaps, you put ones, you cannot permute ones. Therefore, it is going to be n plus 1 ck. N plus 1 ck, right? It's going to be n plus 1 ck, right? Answer this. So this question is a little bit wrong. The reason is they have given n lilies, 15 sunflowers and 14 daffodils. Okay. By nature, okay, you solve it. Okay. You solve it and tell me the answer. Okay. You solve it and tell me the answer. I will tell you. Can someone tell me what is the mistake in this question? Can someone tell me what is the mistake in this question? What is the mistake in this question? Target, I don't know if there are gaps, I will do that. Okay, if there are vacancies, we can do it. Okay, see this, guys. See this. There is a mistake in this question, right? The mistake is whenever they say 10 objects, the objects are distinct by nature. 10 lilies can be there, but all of them can be of different color, different size. Lilies are of same color, but sizes may be different. 15 sunflowers are there, they may be of different sizes, and 14 daffodils are there, they may of different sizes. Actually, this question is distinct to distinct. Actually, this question is distinct to distinct. We have 10 plus 15 plus 14. How many? 10 plus 15 plus 14. So how many are there? 10, 15 and 14 is 39. Okay. 39 distinct objects are there. We have to divide them into two distinct girls, right? Use the box method. So totally there are 39 flowers. Okay. Totally there are 39 flowers. Okay. Now each flower can go to child A or child B. I mean girls is given, right? Yeah, girl A or girl B. So two choices here, two choices here, two choices here, so on, two choices. So answer is supposed to be 2 power 39. But if you look at the options, this option is not there, right? So actually this is supposed to be none. None of this. This is supposed to be none of this. See, when identical word is not given, objects are distinct by nature. Objects are distinct by nature. Now, this question causes confusion because you are going to get 2640 if you consider them as identical. Right? If you consider them as identical, number of flowers A will get and number of flowers B will get is 15 lilies, right? And similarly, number of flowers A will get and number of flowers B will get is 15 sunflowers. Now you are going to get combinations with unlimited. If you consider them as identical, then you are going to get a different answer. If you consider them as identical, then you are going to get a different answer. Now, unfortunately, that answer is also here, 2640. And actual answer should be this one, 2 power 39. But that is not, and none of these is also given. Therefore, you should go for none of this. Always remember, objects are distinct by nature unless they use identical. If they would have used here identical, 10 identical lilies, 5 identical sunflowers and 14 identical, then you can apply the formula n minus 1 plus RCR, which we have discussed, right? See, how did we discuss this problem? We have taken this problem, right? So we have taken this kind of model. What was the problem? 10 red chocolates, blue chocolates, green chocolates. This is a chocolates problem, right? This is a chocolates problem. Okay. We have seen both the models when identical are given, when distinct are given. Okay. Answer this question. This model also we have solved in the class, right? This model also we have class. Okay. We have explained it. We have solved it in the class, right? Acha, 3 girls were given, is it? In the previous question, 3 girls were given. 2 girls only, right? 2 girls only. Take time and answer it. This question will take some time, okay? Yeah, in 3-tier colleges, placements will be very bad, right? If you are from a 3-tier college, only way to get into product-based companies is do masters in good colleges or work for 2 years and learn DSA. And guys, don't forget today at 6 p.m. we have a very important video. Okay. So I'm going to answer the question, should we write gate or not? Okay. Should we write gate or not? I'm going to answer that question. Okay. Take time and do it. Okay. Yeah, Darshan, you will get good marks. Don't worry. Okay. So see this, guys. Whenever I say ascending order, it is not a permutation question, it is a combination question, because when you take numbers and put them in ascending order, there is only one way you can put them, right? So this is a combinations question, not a permutation question. When you see, what are they saying? There are 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. Now what are they saying? You have to divide into 2 distinct pairs of sequences, which means you have to divide them into 2 pairs, C, B and C, right? A is this, okay? Now B and C in such a way that all each is sorted in ascending order. See, let us say you have chosen 1, 2, 3, 4, 5 and given to B, and they are saying B has 5 and C has 3 elements, right? Now when you have chosen 5 elements and given to B, don't do anything, because if you order them in ascending order, there is only one sequence possible. It is not a permutation question, right? So simple way to answer it is, from 8 numbers, you choose 5 numbers that will go to B, and automatically the remaining elements will go to C, and you are going to arrange them in ascending order. Therefore, there is no permutation. So simple answer is 8C 5. From 8 you choose 3 objects, and then they are going to B, and the remaining objects are going to C. Now you can also write like this: the remaining from 3 elements, you are going to choose 3 elements, which is going to be 1. From 8 you have chosen 3, from 3 you have chosen 3. See, this is actually the proof of ordered partition, isn't it? We have done this. So you can directly write 8C5, which is 8 factorial by 5 factorial to 3 factorial, or you can also do it in the way that I have told you in the class. What is it? Now you are going to have some numbers here which are all distinct. All these numbers are distinct, okay? Distinct is given. Now when you are partitioning distinct into 2 parts, these are also named. These groups are also named, which means this is distinct to distinct. This is distinct to distinct, right? And we already know the formula for distinct to distinct. What is the formula for distinct to distinct? Here there are 8 numbers. Now here there is 3, here there is 5 and 3, right? In distinct to distinct, I told you that you get a formula similar to Mississippi problem, right? So what is the formula you are getting? 8 factorial by 8 factorial by 5 factorial into 3 factorial. 8 factorial by 5 factorial into 3 factorial. This is also 8C5. You can directly do it, or you can take it as distinct to distinct, okay, distribution. And see, anyway they are in ascending order, therefore permutation is not possible. No permutations of it. There is only one way, right? So 8 factorial by 5 factorial into 3 factorial. I am top in tier 3 with bad placement, sir. Only 2-3 people got 20 lakhs. So I left placements and completely focused on gate from present second year of batch itself, sir. Anand, please come to offline. Okay. Please come to offline. You are doing well. You will get very good rank. Okay. Answer this question. Okay. This question, take it as homework and answer it. Okay. So this is very simple, but let's discuss in the class. This question, let's discuss in the class. Okay. The reason is, take a screenshot of this question and answer it tomorrow in the class. Okay. Answer this question. This question I have explained you the proof also. Even if you remember the forgot the formula, I have explained you the proof, so you can derive the formula and solve it. Divya, very good. Isha, very good. Isha, very good. Isha. Sridhar, I will take it in the class. That there is something in that question. I will take it in the class. Very good. These are derangements, right? These are derangements. And the question is about D5. The question is about D5. The question is about D5. Right? And what is Dn? The formula is Dn is, see, don't say that I am teaching you formulas. I have derived every formula in the class. How many of you attended my class? Just say, I have derived every formula. Every formula I derived. See, right from n factorial, I derived n factorial, and then I derived npr, and then I derived ncr, and then I derived this one, n factorial by n1 factorial, n2 factorial, so on, nr factorial. I derived it in the class, right? And then what other formulas we derived? NCR, and then n minus 1 plus RCR. This also I derived. And then generating functions. This also I derived. And then derangements. Derangements I didn't give you formula, I derived. Derangements also I derived. Right? Pigeonhole principle I derived. Right? And distribution I derived. Everything I derived in the class. I never asked you to remember any formula. Right? In fact, you can derive the formula in the exam. Right? You can derive them. So don't remember any formulas, you will derive them. Okay? But already you know this, we have done in the class. So sigma r equal to 2 to n minus 1 power r into n factorial by r factorial. N factorial by r factorial. It is dn ka formula. Now they are asking d5. So what is n? N equal to 5. So you are going to put r equal to 2 to 5 minus 1 power. What is r? R into n factorial, which means 5 factorial by r factorial. So alternating terms, you put plus and minus and you can solve it, right? So what is the answer? So answer is 44. Huh? What is the answer you got? 44, yeah. A is the answer. I have derived everything in the class. I will never give you formulas. I will derive every formula. Even in mathematics, I derive everything. Even if you look at my mathematics lectures, I never give you formula. I derive everything. In calculus or probability or linear algebra, I derive everything. I never give you formulas, okay? Answer this question. This is generating function, right? This we have done lot of questions in this model, okay? We have solved lot of questions in this model in the class. We have solved lot of questions in this model in the class, right? Try it. Already CN and OS lectures are available. You can start watching, Anant. So you are getting I plus 1. Huh? So how are you going to solve it? See, 1 by 1 minus x power minus 2, sorry, plus 2. It can be written as 1 minus x power minus 2, right? So it is in the form of 1 minus x power minus n. Now how are you going to write it? Sigma r equal to 0 to infinity, sigma r equal to 0 to infinity, right? N minus 1 plus r cr into x power r. Now they are asking you this. What is this? Right? Instead of r they have put I. Instead of r they have put I. So here you can put I, and here you can put I, here you can put I, and here you can put I, right? So they are asking you this. What is n minus 1 plus I ci? Now in the options, so you can write it as n minus 1 plus I ci. So this can be written as n minus 1, you have to subtract this one from this. You are going to get n minus 1. N minus 1 plus RCN. It is also n minus 1C, n minus 1 plus RC, n minus 1, right? Now, what is n? So, n is 2. So, you are going to substitute 2 here. So, you are going to get I plus 1C 1, which is nothing but I plus 1, which is I plus 1. B is the answer, which is I plus 1, B is the answer, right? Yeah, you can thank Vasudha for the notes, Anant. Okay, answer the next question. Okay, try to answer this. This is going to take some time. Try to answer this. Very good. So what is it they are asking? Suppose that a robot is placed on a Cartesian plane. At each step, it is allowed to move either up or right. That is, at a I plus I comma j, it can move I plus 1 comma j or I comma j plus 1. Now the question is, how many distinct pairs, how many different paths, distinct paths are there for the robot to reach the top 10 comma 10 starting from the position 0 comma 0, right? So let's take a 4 by 4 grid, okay? Not 10 by 10. Let's take, I think if I need 4 comma 4, I have to have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this is, let us say this is 0, 0. Okay, this is 0, 0. This is 0, 1. This is 0, 2. This is 0, 3. This is 0, 4. Right? And this is 1, 4. This is 2, 4. This is 3, 4. And this is 4, 4. You can fill the entire thing. Okay. Now you have to reach from here to here. Every time you can go right or go up. Right? So for example, I am giving you one possible path. For example, I am giving you one possible path. From here to here, 1, 2, 3, 4, 1, 2, 3, 4. Right? So, if I have to reach 4, 4 from 0, 0, I have to take 4 right moves and 4 up moves. There can be any combination of that. There can be any combination of that. Similarly, if I have to go from 0, 0 to 10, 10, there will be 10 right moves and then 10 up moves. There can be any combination of jumbling can occur here. Any kind of jumbling can occur here. See, there are various paths. I will go like this, then I will go like this. I will go up, right, up, right, up, right, up, right. How many are there? 1, 2, 3, 4. 3 ups, 4, 1, 2, 3, 4. 4 ups and 4 rights. 4 ups are there and 4 rights are there. 4 ups are there and 4 rights are there. 4 ups are there and 4 rights are there. Okay. So totally 10 rights are there, 20. So what is this? It is nothing but how many ways can you write 10 R's and 10 U's in a 20 box, right? Or how many total permutations are there of 10 R letters and 10 U letters? This is Mississippi, right? The question is nothing but Mississippi. Mississippi. Isn't it? This is Mississippi question. So what is the Mississippi formula? N factorial by n1 factorial, n2 factorial, so on n r factorial. So what is this? N means total number. 10 plus 10 is 20 divided by 10 factorial into 10 factorial. That's it. Right? So this is 20 C10. A is the answer. 20 C10. A is the answer. Right? Now answer this question. Now answer this question. Okay. So see, how are you going to write this? So what they are trying to say is, suppose that robot is placed on a Cartesian product, Cartesian plane. So this is the normal. Suppose the robot is not allowed to transfer the line segment 4, 4 to 5, 5, which means from 4, 4 it should not go to 5, 5. With this constraint, how many distinct paths are there for the robot to reach 10, 10 from 0, 0? So what are they saying? One path has to be not taken, one edge, right? One line segment, okay, traverse the line. One line segment should not be taken. What is the line segment? 4, 4 and 5, 5. So there will be lot of paths which will not go through 4, 4 and 5, 5, from 4, 4 to 5, 4, right? But the problem is, see, you cannot go from 4, 4 to 5, 4. There will be lot of paths which will go through 4, 4 to 5, 4, and it will be lot of cases to consider. Whenever you have lot of cases, go by complementary method, right? So what is the total number of paths? We got 20 C10 is the total number of paths, right? Now from this you subtract the paths which are From this, you subtract the paths which are going from 4, 4 to 5, 4. Subtract the paths which are going from 4, 4 to 5, 4. So what we do? We will start at 0, 0 and then we will go till 4, 4 and then we will take the given line segment and we will reach 5, 4, and from 5, 4 we are supposed to go to 10, 10. From 5, 4 we are supposed to go to 10, 10, right? Now from 0 to 4, 4, how many ups and rights are there? So this is totally there are 8 rights and 8 ups, and you are going to write 8C4, 8 factorial by 4 factorial into 4 factorial, and then there is only one way you can choose this path, so multiply it 1, and now after that from 5, 4 you have to reach 10, 10. So how many ups are there? Ups are 5, and how many 5, 5 to ups are 5. From 5, 5 you have to go to 10, 10. So it is going to be 6. Yeah. So ups are 5 and then rights are 6. From 4 if I have to reach 10, then the right moves are 6. So this is nothing but 11 factorial by 5 factorial. 11C5. Okay. So this is 11C5. See, how did I write this formula? There are Mississippis. This is a Mississippi of 10 Rs and 10 ups. This is a Mississippi of 4 Rs and 4 ups. This is a Mississippi of 5 Rs and 6 ups. So all these are Mississippi problems only, right? But then I have written in terms of combinatorics because answer is given in terms of NCR. That is why I have written like this. Actually, what will come? 20 factorial by 10 factorial into 10 factorial, 8 factorial by 4 factorial into 5 factorial, and 11 factorial by 5 factorial into 6 factorial. Right? Actually, that is what you get. That is what you get, right? No Samira Nandi. We cannot do like that. Okay. Answer this question. How many ways can B blue balls and R red balls be distributed in n distinct boxes? So it is chocolate in the boxes problem only, right? It is chocolate in the boxes problem only, right? Answer this question, guys. Answer this, everyone. again, this question is also wrong. Okay, so they see, when there are B blue balls and R red balls, blue balls can be of different sizes, red balls can be of different sizes, identical word is given, not given. Therefore, B blue balls and R blue balls, R red balls can be distributed in n boxes, right? So if you see this, I have blue distinct balls, B distinct blue balls, right? And then R distinct red balls, R distinct red balls. Now all these objects are distinct. You can put them, each box you can assume them as the object, right? So each box is a ball. Now each ball can be assigned to n people. Each ball can be assigned to n people, 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 right? Now what do you get? N power B plus R. This should be the answer, but in the answers this option is not given. So what they might have assumed is B balls are identical. B balls are identical and R balls are identical, right? Right? Now if they are identical, it is similar to chocolate problem. How many ways can you distribute blue chocolates, 10 blue chocolates, 10 red chocolates into 4 boxes or something like that? Okay, so you are going to set the equation up. So if they are identical, see, in the options it is very clear that n minus 1 plus RCR is applied. Okay, 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 okay. Sridhar, I explained everything in the class. I have solved every model in the class. Why are you asking again, Sridhar? I have solved everything. I have solved all these models possible. There are only 3 models possible, Sridhar. I told you in the class, Acha, you are not registered. Okay, if you are not registered, please don't ask me doubts, okay? Because I have solved everything in the class. If you are not registered, watch my classes, you will understand this, okay? So guys, now identical and identical. It has to be distributed among n people or n boxes, n distinct boxes, right? So x1 plus x2 plus x3, so on xn. First you distribute B blue balls. We have seen the exact question in the class, right? Now x1 plus x2 plus x3 plus so on xn, you distribute R red balls, right? Now what is this? And each x1, x2, x3, there are no constraints, which means they can go from 0 to B, which means it is infinite repetition, unlimited repetition. This is combination with unlimited repetition, where, see, how can you assume this? How many non-negative integral solutions are there for the equation x1 plus x2 plus x3 plus so on xn is equal to B? How many non-negative integral solutions are there, right? And what is the formula? Formula is n minus 1 plus RCR, and I told you clearly that right hand is going to be R and left hand number of variables is going to be n. So what is the answer for the first one? N minus 1 plus R. What is R? R is B, C, B. N minus 1 plus R, CR, right? And then what is the answer for this? So these two have to happen, right? B balls should be distributed and R balls should be distributed. Therefore, we are going to take product. So n minus 1 plus C, n minus 1 plus R, CR. N minus 1 plus R, CR. Because right hand side is R. N minus 1 plus CR. So you can substitute and get the answers, right? Right? So see, this one can also be written as, so what this entire thing can be written as n minus 1 plus B divided by B factorial into n minus 1 factorial. And what is this? N minus 1 plus R divided by n minus 1 factorial into R factorial, right? Now you multiply these two, I think you are getting what option 1, yeah. right? But if option 1 has to be correct, they should have mentioned identical and identical. We cannot assume that if B blue balls are given, they can be of different sizes. Objects are always distinct by nature, right? So sometimes just look at the options and you have to imagine what that guy has imagined. But for such questions, we can claim and get full marks. If any such question comes with this kind of dilemma, right? We can actually raise objection and get the full marks for this question. Okay, this question is wrong. They should have given identical. What is the actual answer for this question? Actual answer for this question is, where did I write it? Yeah, here, n power b plus r. But only if identical is given, then the answer is going to be n minus 1 plus rcr. N minus 1 plus rcr, right? Okay. Now answer this question. Which of the following is closed form expression for the generating function of the sequence 2n plus 1? Closed form. Try to answer it. Try to answer it. We have solved this class in terms of r. They have given it in terms of n, right? Right? Try it. We have solved this model in the class. Try it, everyone. तुझे मिलके लगा है ये. So guys, we have solved this in the class, right? See, only difference they have given is in class we have solved for AR, but they are saying AN equal to 2n plus 1, right? Right? So A not equal to 3, A1 equal to 5, like that, 3, 5, so on, right? And now they are asking for the closed representation of the generating function. Okay? Okay? Now write an equal to 2n plus 3, 2n plus 3, right? Then what is going to be generating function? Generating function, let us say a of x. Generating function, let us say a of x is equal to sigma n equal to 0 to infinity, n equal to 0 to infinity, 2n plus 3 into x power n, into x power n. Now, how are you going to write it? 2 into sigma n equal to 0 to infinity n into x power n plus sigma n equal to 0 to infinity, here 3 will come out, and then xn, right? Now we have this formula for this and formula for this. We have solved both of them in the class, right? So what is n into n into n power x power n? N into x power n is x by 1 minus x square. We have solved it in the class. Now what about this? Plus 3 into x power n is nothing but 1 by 3, 1 by 1 minus x, right? So if you solve it, you are going to get 3 minus x divided by 1 minus x whole square. D, you are going to get D. 3 minus x divided by 1 minus x whole square. 3 minus x divided by 1 minus x whole square. Option D. Very few people have answered it. Now answer this. A florist sells 5 different colors. A florist sells roses of 5 different colors. How many bunches of half dozen roses are there? It is half dozen, not dozen. So this is 6. Okay. How many bunches of half dozen roses can be there? Half dozen roses can be there. Answer this question. Okay. So what is the answer you got? B 210, right? So it is B 210. See, how are you going to solve it? See, there are 5 different colors, right? Let us say whip jar. V, I, B, G, Y. Okay, let us say only 5 colors are there. Violet, indigo, blue, green, yellow. Now, you have to make 6. That's it. See, they are saying 5 different colors of roses and they didn't say the number, which means they can be up to infinity. So, how are you going to form the equation? The equation is going to be violet color roses plus indigo color roses plus blue color roses plus green color roses plus yellow color roses. Put all of them put together has to be 6. There are no constraints given, which means for each one of them, let us say xi, they can go from 0 to 6, infinity, 0 to right hand side. See, there is no point in going beyond 6 because that will make 7. We have to go only 6, right? So lower bound is not given. So lower bound is 0, upper bound is 6, which means it is as good as infinity, right? So this comes under combination with unlimited repetition. We have solved hell a lot of models of this in the class, right? You should easily be able to answer it. What is R? I told you that R is always right hand side and N is the number of variables on the left hand side. How many variables are there? 5. N minus 1 plus R C R. That's it. So what is this? This is 6 plus 10. 10C6. 10C6 or 10C4? 10C6 or 10C4, which is 210. 210 is the answer, okay? Now answer this question. Evaluate the sequence 1 into 3, 2 into 4, 3 into 5 up to n terms. We need n terms. We need sum of n terms. Tenth class maths. 10th class mathematics. Nagasai, Chaitran, Siva, very good. All of you are from? Where are you all from? Okay. So Sn is nothing but sigma n equal to r, I will write r, sigma r equal to 1 to n, sum of first numbers. Okay. Sigma r equal to 1 to n, r into r plus 2, right? R into r plus 2, r into r plus 2, r into r plus 2. Now expand it, right? So this is sigma r equal to 1 to n r square plus 2 into sigma r equal to 1 to n r equal to 1 to n r. This is sum of n square terms. This is sum of n terms. What is this? N into n plus 1 into 2n plus 1 by 6 plus what is this? N into n plus 1 by 2. You just simplify it, okay? Right? So this is 2 is there here. Okay? So you are going to get A, option A. You are going to get option A, right? Right? Okay. Now answer this. The number of ways the numbers 1 to 15 are assigned to 25 squares of 5 by 5 having 10 empty spaces. Try it, guys. బయటకి వెళ్ళి వస్తున్నా బయట చేసుకో బయటకి వెళ్ళాము Okay. Okay. So this is a simple question. See, what they are saying is there is a 5 by 5 grid. There is a 5 by 5 grid which are having 25. 1, 2, 3, 4, 5. 1, 2, 3. You don't have to draw this actually. This is nothing but 25 seats are available and 15 people wants to sit. You can convert into that problem. See, all the grids are different because grids have a, why did they get grid? Because every grid is a different chair. Okay. Now there are 25 chairs and how many people are there? 1 to 15 are numbered. So you can take them as people who are distinct, right? So 15 people have to sit in 25 chairs. How many ways? 15 people have to sit in 25 ways. So simple answer is from 25 chairs, you choose 15 chairs and then once you have chosen 15 chairs, you permute you have chosen 15 chairs and you assign them the people to the chairs, you can permute them in 15 factorial ways. You can permute them in 15 factorial ways. So what is this? This is 25 divided by 10 factorial into 15 factorial into 15 factorial, right? Cancel it out. Or you can also consider it as permutation with no repetitions. There are no repetitions, right? And the formula is NPR directly. What is N? 25. What is P? P is 15. 25P 15. Directly you can write like this or you can write like this, right? If would have been given instead of 1 to 15, let us say they have given 15 ones, then what happens, guys? Instead of 1 to 15, if they have given 15 ones, then what happens? 15 ones. Then you just have to choose the chairs. okay, or choose the places 15. You cannot permute them. You cannot permute them. It will just be 25C 15. Permutation will become combination when there are repetitions. When there are repetitions, right? Okay, answer the next question. Let A equal to something, B equal to something. So this is N is, what happened here? Some symbol is missing. N is greater than or equal to, 1 minute, let me check the question. I didn't check it, some symbol is missing there. What is the symbol that is missing there? N is greater than or equal to 1. N is greater than or equal to. N is greater than or equal to. Which one of the following is an integer? ఇంటికి వెళ్ళలేదు నువ్వు. See, when it is a counting problem, counting problems are always having to have a number from 1 to infinity, right? Between 1 and infinity. So they will not have fractions. In order to understand this, you have to understand that these two are counting problems. When these two are counting problems, both are going to be integers. Okay. So answer is going to be C. Both are going to be integers. Can someone explain me? We have done this in the class, isn't it? Can someone explain me what is A and what is B? Can someone explain me what is A and what is B? In words, prepare a story. What is A and what is B? Can someone explain me what is A and what is B? See, A is what? A is what? Distributing 2n distinct objects. Distributing 2n distinct objects into n groups of 2 groups of n each. 2 groups of n each. 2 groups of n each, right? And this is unordered partitioning because 2 groups are not named. 2 groups are not named, right? Right? Then what do you get? 2n factorial divided by n factorial into n factorial, which is n factorial whole square into 2 factorial. We have solved it in the class. Now what is this? Distributing or separating 2n objects into groups of 2, n groups of 2, n groups of 2. Then what do we get? 2n factorial divided by 2 factorial power n into n factorial. This is also unordered partitioning, right? These two are counting problems, isn't it? This is a counting problem, this is a counting problem, and for every counting problem we get an integer. We will not get fractions. Remember that. For every counting problem we get answer as an integer. We cannot say there are one point ways of doing it. We can say either one way of doing it or two ways of doing it or 100 ways of doing it, but then we will never say 1.5, 2.5. There will be no fraction. So these two numbers are definitely integers. A and B is the answer. Okay. We have done the same model in the class. I have taken these two questions and I have explained in the class. Okay. And we have seen many other models like this. Okay. Now answer this question. Take time and answer it. Okay. Take time and answer it. Okay. Take time and answer it. This is an NFA, right? This is an NFA. Okay. Fine. So simple, right? Okay. What is the answer? Try it. Everyone try it. Take time. Okay. Take time and try it. What is the answer? Chetran is saying D. If it is D, what is the answer? Samira Nandi, very good. Samiran Nandi, very good. So guys, see this. If you have to reach from initial state to final state, there are multiple paths, right? I can go like this, go like this, go like this, go like this, go like this. So I will get X, Y, Z followed by A, B, C. Or I will go like this, go like this, go like this, and then go like this, go like this, go like this. Here, A, B, C followed by X, Y, Z. Or I can take any path. I can go like this and then go up, which means X, then A, and then I will go like this and then go right, which means B and Y, and then I will go like this and I will go right, which means C and Z. So if you see, look at this, they are all six letter strings in which X, Y, Z are always ordered and A, B, C are always ordered, right? So you have 6 blanks, 1, 2, 3, 4, 5, 6, 6 blanks. From 6 blanks, choose 3 blanks, right? And you place X, Y, Z there. Okay, from 6 blanks, choose 3 blanks and you place X, Y, Z. There will be no permutations of it. Once you have chosen 3 places, you are going to assign them to X, Y, Z, and X, Y, and Z will not permute among themselves. Now, how many blanks are remaining? 1, 2, 3, right? From the 3 blanks, choose 3 blanks for A, B, C. So, this is just one way. So, the answer is 6C3. Because even when you chose A, B, C, there is only one way. You cannot jumble A, B, and C, right? So, the answer is 6C3, right? And 6C3 is 20. 6C3 is 20. 6C3 is 20, right? Answer the next question. How many positive integral solutions are there for the equation x plus y plus z plus t equals 20? We have solved hundreds of problems like this. What is the answer? So you are going to see how many positive integral solutions are there. This is n plus 1, n minus 1 plus RCR, right? So n is 4, R is right hand side, which is 20. So n minus 1 plus RCR. What is this? 23 CR. I made some mistake. Why am I getting n minus 1 plus R CR? I think I have written question wrong. 1 minute. Huh? Oh, it is number of positive integral solutions, which means I have to write something here. Okay. Positive integral solutions, not zero. It has to be positive. So there is a lower bound. What is the lower bound? X is greater than or equal to 1, y is greater than or equal to 1, z is greater than or equal to 1, t is greater than or equal to 1, right? Now get rid of these lower bounds. How do you get rid of the lower bounds? There are 1, 2, 3, 4. You subtract, you give x1, y1, z1, t1. See, what is the question? How many ways can you distribute 20 identical balls into 4 buckets? 20 identical balls into 4 buckets, right? Now, in such a way that each bucket gets at least one ball. Now give one ball here, one ball here, one ball here, one ball here. Now it will become 0, right? And it will become 16. So R is equal to 16 now and n equal to 4 now. So n minus 1 plus R, which means 4 minus 1 plus 16 C 16. N minus 1 plus R CR, right? So this is going to be 19C 16. 19C 16. 19C 16. Okay, do the next one. So A is a set of cardinality n. The number of subsets having odd cardinality. Odd cardinality means how many odd 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 sized subsets can you get? How many odd sized subsets that you get? Okay. What is the answer? C. 2 power n minus 1. Right? We have solved it in the class. Even or odd. Right? See, n cardinality and everything has to be odd. So what is this? nc1 plus nc3 plus so on. And we know that this is equal to nc0 plus nc2 plus so on. And we know that this is equal to 2 power n minus 1. Right? We solved it in the class. Okay. Okay. Answer this question. So see this. Okay. Answer this. Okay, everyone. So you can take a 4 by 4 grid and answer it, right? Now don't take 8 by 8, that will be too big. 1, 2, 3, 4. 1, 2, 3, 4. Now this is 0, 0. This is 0, 1. This is 0, 2. This is 0, 3. And this is 1, 0. Sorry, 1, 3. This is 2, 3. And this is 3, 3. Now if you are already here, you can make 3 rights and 3 ups. So this is a little bit different question. You have 3 rights and 3 ups, not 4 rights and 4 ups, right? So we have 3 rights and 3 ups for a 4 by 4 grid. For a 8 by 8 grid, there will be 7 rights and 7 ups. For a 8 by 8 grid, there will be 7 rights and 7 ups. So we have a string of 14. We have a string of 14. And out of you have to arrange, how many jumbles can you make using 7 R's and 7 U's? Mississippi problem, right? We have 7 R's and 7 U's. How many jumbles? How many jumbles are there? Right? This is a Mississippi problem. Right? Limited repetition. This is limited repetition. And this is combinatorics with permutations with limited repetitions. Permutations with limited repetitions, right? So what is it? It is 14 factorial. Total 14 are there. 7 are repeating. 7 are repeating. 14 factorial by 7 factorial to 7 factorial. I think answer is not given. What they have done is, I think they have taken 8 plus 8, 16 they have taken. But if you start from 0, 0, there will be 1, 2, 3, 1, 2, 3 moves only. In a 4 by 4, you have 3 moves right, 2, 3 moves up, right? So they have started, they are taking it as, oh, square grid is given. I think even square grid is also same, right? 1, 2, 3, 4. 1, 2, 3, 4. If you are at this point, 1, 2, 3. Only 3 are there. 1, 2, 3. Only 3 are there. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I'm right. Okay, so this is going to be, actual answer is 14 factorial by 7 factorial to 7 factorial, but by mistake they have given 16 factorial. If they should have given 16 factorial, then they should clearly mention that from 0 0 to 8 8. They didn't mention 8 8. It is 8 by 8 grid. So you have 7 moves right, 7 moves up. Can you solve this answer? Can you tell me this answer? 14 factorial by 7 factorial to 7 factorial. Can you tell me this answer? 14 factorial by 7 factorial to 7 factorial. Use calci and tell me. Use your calculator and tell me. Use your calculator and tell me the answer. Answer is 3432. This is not given. Okay. Just be careful with those. Okay. How many binary strings of length 8 either start with A, start with 1, end with 0 0? Start with 1, end with 0 0. Start with 1 or end with 2 zeros. Start with 1 bit and end with 2 zeros. Very good. So answer is 160, right? So how many of them start with 1? 2 power 7. How many of you end with 0? 2, 2 power 6, 0, 0. Minus starting with 1 and ending with 0, 2 power 5. So you are going to get 160, right? Answer this. Answer this. What is the answer for this? This we have seen in the class, right? So how many positive integers not exceeding 1000 means 1 to 1000. So divisible by 7 means 1000 by 7 plus 1000 by 11, inclusion-exclusion principle, minus 1000 by 77. So what was the answer you are getting? You can solve it, okay? Now answer this. Find the largest integer value of x satisfying this. Find the largest integer value of x satisfying this. Numerical answer type. Find the largest integer value satisfying this. Try it. You have to simply substitute in the formula and then get it. Okay, so I'm not giving you the options intentionally. Okay, you can solve it. Okay, what is the answer for this? I think I have not solved it. So yeah, I have not solved it, I guess. Okay, I have not solved it. Answer this question. There have to be at least 3 women. Okay, so what is the answer for this? 91. You are getting 91. See, a group consists of 4 women and 7 men, which means there are 17 people, out of which 4 are women and then 7 are men. Now what should we take? How many ways we can take a team of 5 members such that there are at least 3 women, right? So women can be 3, women can be 4, or women can be 5. Now if women are 3, men are going to be 2, men are going to be 1, men are going to be 0. So what is the answer? Answer is 4C1 into 7C3 plus, sorry, 4C1 into 7C4 plus 4C0 into 7C5. Right? I think you are getting 91. I don't know the answer. I have to check it. I think I didn't solve it. I have not solved it, I guess. 91. Yeah, 91 is the answer. 91 is the answer. Okay. Now answer this. Now answer this. So find the number of 7-digit integers with a sum equal to 11 formed by 1, 2 and 3 only. Formed by 1, 2 and 3 only. Formed by 1, 2 and 3 only. It is a difficult question. Try it. Try it, take time and try it. Take time and try it. Okay. So let me solve it, guys. Let me solve it. So first you have to frame the equation. Okay. So I don't have a lot of space. Let me do it from here. Okay. So how many of you have got the answer? So the answer is, how many of you got it? No one has got the answer. Do you want more time to try? Do you want more time to try? So such models we have solved already in the class, right? Okay, solve it. Take more time. This is with limited. So this is with limited repetition. Limited repetition is generating functions, right? You have to use generating functions here. Not very easy, but we have solved such models, many models in the class. I have solved many questions of this model, right? You should be able to do that, but since this is the practice session, even if you are not able to do that, that's fine. Don't get disappointed with this question. See, if there is a simple question, you should definitely be. Try it, guys. If I solve it, I will be taking away this opportunity. This is a great opportunity to learn about generating functions. I don't want to take away that fun from you. If I solve it, you will not have fun. Try it. Wow, someone has got the answer, man. Who is this guy? Chaitran. Chaitran, love you. Chaitran, you are going to get first rank. Okay, I'll make sure that you'll get first rank, and I'm promising you on in the public, on a public domain. I'm promising you, Chaitran, you are going to be the first ranker in 2027. Let's work hard. Okay, love you, Chaitran. Only one person answered it, and he is my weapon. Good, good, good. Okay, let me answer it. So, Chaitran, I'm very happy, man. You made my day. I'm coming to meet you. Okay, just be in the office. Immediately after the class, I will have lunch and come and meet you. Okay, love you, Chaitran. Okay, I thought no one would answer it. Chaitran, this class is worth now. Chaitran, amazing. Chaitran, love you. Okay, cool. Let's answer this. Okay. So we have solved the same models in the class. I don't know why you people are not able to answer it. See, sum of how much? Find the number of 7-digit integers with sum equal to 11. So how are you going to set up? See, I need the entire board now. Okay, this is going to be big. So I will start from here. Okay. So find the number of 7-digit integers with sum equal to 11. So you have to be 7-digit integers. 1, 2, 3, 4, 5, 6, 7. Okay. Now let us call them x1, x2, x3, x4, x5, x6, x7. Okay. And the numbers range is 1, 2 and 3. These are the constraints given. So what is it? x1 plus x2 plus x3 plus x4 so on x power 7 is equal to 11. Now what are the constraints given? 1 is less than or equal to x1 is less than or equal to 3. Similarly, the same constraint for x2, x3 so on, right? Now get rid of the lower constraint. See what is this problem similar to? Distributing 11 balls into 1 minute. Right? So distributing, where is it? What is it? Distributing 11 balls into 7 buckets. Cool. Get rid of the lower constraint. Okay. So what is the question? Each bucket should get at least 1 ball. I will put 1 ball here, 1 ball here, 1 ball here and 1 ball here. 7 balls are gone. Now the lower constraint is removed. Now the constraint is 0 less than or equal to x1 less than or equal to 2. Subtract 1 here and 1 here. Add 1 here. Now this one will become 7. Right? So no, this one will become 11 minus 7, which is 4. Got it? Now this is limited repetition. See this, right hand side is 4, but each variable can go up to 2 only. Right hand side is 4 and each variable is going to get up to 2 only, right? Which means it is limited repetition. Limited repetition. Right? In limited repetition, what do you do? What do you do? Generating functions, right? So x1 can be, the generating function x1 can be, x3 can be 0 or x1 can be 1 or x1 can be 2. 0, 1, 2. Now how many are there variables? 7 variables. Multiply with 7 is equal to, this is the generating function. This is the generating function, right? So what is that we have to find out? We have to find out the quotient of x power 4. In this, we have to find out the quotient of x power 4. X power 4, right? Now how are you going to write it? A into 1 minus r power n divided by 1 minus r 1 minus r, a into 1 minus r power n divided by 1 minus r whole power 7. Now what is that you want in this? Quotient of x power 4. Quotient of x power 4. So I will just divide it into two parts. Okay. So one part is going to be 1 minus x power 3 whole power 7 into 1 minus x power minus 7. 1 minus x power minus 7. Right. Now what is this? This is equal to, let us expand it. Okay. Now what is 1 minus x power 3? So this one I can write it as sigma. This one I can write it as expansion of sigma r equal to 0 to 7. Okay. Sigma r equal to 0 to 7 minus x power 3 power r minus x power 3 power r. Now what is the expansion of this? Sigma r equal to 0 to infinity n minus 1 plus r, which means 7 minus 1 plus, what is r here? R is right, CR into x power r. 7 minus 1 r CR, right? Now you simplify it simply. Okay. Now you can simplify it. You can simplify it. Right. Right. So how can you simplify it? It is r plus c. It is 6 plus r CR. You can simplify it into 6 plus r C6. 6 plus r C6. That is it, right? Yeah, 6 plus r C6. Right? Now what do we want? We want the powers of 4. So let me expand it. If I put r equal to 0, I am going to get 1. If I put r equal to 0, I am going to get 1. I am going to get 1. Isn't it? If I put r equal to 0, this is minus x power 3. Yeah. So here we have 7c3 also. 7cr. 7cr into minus x power 3. 7cr into minus x power 3 power r. Right. Now in both of these we want the power of x power 4, quotient of, so let me write it again, 6 plus 1, 6 plus r CR x power r. So what do we want? We want the quotient of x power 4. Quotient of x power 4. Right? So how are you going to get the quotient of x power 4? Initially I'm going to expand this. Okay, I'm going to expand this. If I write r equal to 0, this is 7c naught into 1. If I put r equal to 1, this is going to be 7c1 into minus x power 3. If I put r equal to 2, this will become x power 3 whole square, which means x power 6. So we don't want remaining terms. We just want these two terms. Isn't it? We just want these two terms. Right? Now this, leave it as it is. Sigma r equal to 0 to infinity. You can write 6 plus r C6 x power r. Right? Now using these two terms, you have to calculate this. See, now if I want x power r, this is 1, right? If I want x power r, this should be 4. This should be 4. If I want x power 4, this should be 4, because here there is 1, right? So what is this? 10c6. 10c6, right? Plus here minus 7c1 into, this is minus, right? So let me put minus. This is minus. Minus x power 3 means minus 7c1 into, here there is already x power 3. Here I want x power 1, which is nothing but 6 plus 1 C6, which means 7 C6, right? Now if you solve it, you are going to get 191 or 161. 161. You are going to get 161. You are going to get 161. Okay, cool. Chaitran, you are going to get some good gift. Ask me anything today. Whatever you ask, I'll give you. I'm coming to the office after the class. Whatever you ask, I'll give you. Okay, you ask for anything. Chaitran, are you there? Tell me what you want in the chat. Tell me what you want. Anything you ask me, anything. I have Harley Davidson bike, which is 60 lakhs. I will give that to you. Okay. If you get first rank in GATE 2027, I have a 60 lakh worth Harley Davidson bike, which I don't use. It is just there. I will give you that bike. Okay. Cool. Now find the number of odd integers between 1000 and 999 having distinct digits. Odd integers, right? This is a simple question, right? This is a simple question. You can do it. This is what we have seen. Number of ways 4 fruits can be chosen out of 8 fruits so as to exclude largest fruit. Answer this. This is also a simple question, 10th max, right? 10th max. Okay, so this is a stupid question. Solve this. This is an interesting question. Okay, solve this question. Take time and solve this. Take time and solve this. Try it, guys. Chaitran, what is the answer? Wow, who is this guy? Sridhar. Very good. 89 is the answer. Okay, 89 is the answer. Let's look at the question. A pennant is a sequence of numbers, each number being 1 or 2, which means there are only two numbers. There are only two numbers, 1 or 2. and it is a sequence of numbers, each number being 1 or 2. A n pennant is a sequence with sum equal to n, which means you have to make sum equal to n. For example, 113 is a 4 pennant, which means if I use 112, this sum is 4 pennant, okay? And the set of all 1 pennants is 1. The set of all 2 pennants, which means if I have to get sum of 2, I can directly take 2 or 1 1. And the set of all 3 pennants are 2 1, 1 2, 1 1 1, right? Note that the pennant 1 comma 2 is not same as 2 comma 1, which means permutations are also there, right? The number of 10 pennants are, which means we have to get sum as 10, right? So see, what is it? Let us assume that x1 is the number of ones, okay? Now x2 is number of twos, number of twos, number of twos. Now what is the equation? What is the equation? So if I take x1 is number of ones plus number of twos are x2. So what is the total sum? See this. If there are x1 ones and x2 twos, what is the total sum? x1, 1 into x1, 1 into x1 plus 2 into x2 should be equal to 10. Should be equal to 10. Should be equal to 10. Right? Right? 1 into x1 plus 2 into x2 should be equal to 10. Should be equal to 10. Right? Cool. Now what are all the combinations that will make it up? Okay. Now if I take 0 ones, I can take 5 twos. Sum is going to be 10. If I take 1 1, which means here the value is 1, 10 minus 1 is 9 and x2 is coming fractional. So this is not possible. Now what about 2 ones? If I take 2 ones, I can take 4 twos. If I take 3 ones, so here I am getting 7 by 2, x2 is 7 by 2, not possible. If I take 4 ones, if I take 4 ones, then this is going to be 6, it is going to be 3, right? If I take 5 ones, it is not possible. If I take 6 ones, if I take 6 here, then it is going to be 4 and x2 is going to be 2. If I take 7 ones, it is not possible. If I take 8 ones, then x2 is going to be 1. If I take 9 ones, this is not possible because 1 by 2 you are getting for x2. And if I take 10 ones, x2 is going to be 0. So what are all the valid cases here? What are all the valid cases? 2 ones and 0 ones and 5 twos, which means 2 2 2 2 2. Now how many permutations can you make with this? The permutations you can make with this is one only, right? Now if I take this, what is this? 2 ones and 4 twos. 1 2, 2 ones and 4 twos, 2 2 2 2. How many permutations can you make out of it? It is Mississippi, right? 2 ones and 4 twos, Mississippi, which means 6 factorial divided by 2 factorial into 4 factorial, right? Now what about this case? 4 ones, which means 1 2 3 4, 4 ones and then 3 twos, 2 2 2. Now again Mississippi problem, 1 2 3 4 5 6 7. 7 factorial divided by 4 factorial into 3 factorial. What about this one? 6 ones, 1 2 3 4 5 6 ones and then 2 twos, right? Now what is this going to be? 6 plus 2 is 8. So 8 factorial divided by 6 factorial into 2 factorial, right? Now what about this? How many ones are there? 8 ones are there. 1 2 3 4 5 6 7 8 and then 1 2 is there, right? So what is the answer? 8 plus 1 is 9. So 9 factorial divided by 1 2 3 4 8. 8 factorial into 1 factorial, right? And similarly 10 ones. 10 ones we can arrange them in only one way. So now if you add all of this, you are going to get the answer, okay? If you add all of this, you are going to get the answer. And the answer is, let me check the answer. Yeah, very good. Answer is 89. Very good, Chaitran. And very good, Samiran. Sridhar, very good. So answer is 89. So the answer is 89. Okay. Answer this question. Anyway, number of prime factor, this is prime factorization question. Number of, we have done that. Okay. Answer this question. It is a simple question. Let me answer it. Okay. So you can rewrite it as x equal to 1 to 99. You can rewrite it as 1 by x minus 1 by x plus 1. 1 by x minus 1 by x plus 1, right? Now what is this going to be? 1 by 1 minus 1 by 2 plus 1 1 by 2. So this one gets cancelled, so on. At the end you are going to get minus 1 by 100, right? So this is going to be 1 minus 0.01, which is nothing but 0.99. 0.99 is the answer, right? And number of divisors, this you know, you can solve it. And now quotient of x power 12 in this is interesting question. Again the same question like this. Try it, guys. Quotient of x power 9. Quotient of x power 9. Quotient of x power 9. Sorry, quotient of x power 12. Quotient of x power 12. So you got 10. Yeah, answer is 10. Okay, very good. How many of you have got 10? Sridhar, Chaitran and Siva. Siva, very good, Siva. Okay. So let's answer this. Okay. So see, you can pull out x power 3 as common. X power 3, x power 4 is there, right? So pull out x power 3 as common. Then this is going to be 1 plus x square plus so on whole power 3. Whole power 3. And this is x cube into 1 by 1 minus x whole power 3. Isn't it? Yeah, x power 9. If I pull out x cube as common, I'm going to get x power 9, right? X power 9. This is x power 9. Okay. Now this is x power 9 into sigma r equal to 0 to infinity n minus 1. So this is what is this, guys? This is 1 minus x power minus 3, right? So n is 3. So n minus 1 plus r, right? Plus r cr into x power r. Now what do you want? We want x power 3. You can simplify it even further. So this is r plus 2c2. I can write it as rc2. This is rc2 into x power r, right? Now already I have 9. What should be the power of r? What should be the power of x? The power of x has to be 3, so that it will become 12. So if r is 3, this is going to be 3c2. This is going to be 3c2. No, there is a small mistake. Okay. So I want the quotient of x power 3 here. Okay. So if r equal to this part, if r equal to 3, then I am going to get, here also there is R, okay, yeah. So this is RC2. This is, I have written it wrong. This is R plus 2C2. R plus 2C2. So R equal to 3 means this is going to be 5C2. 5C2 is 10. 5C2 is 10. Okay. Now answer the last question. If the ordinary generating function of a sequence is given by this, then what is A3 minus A0? What is A3 minus A0? Let me check the question once. There is a small mistake. Okay. So 1 plus z divided by 1 minus z whole power 3. 1 plus z divided by 1 minus z whole power 3. Okay, comma is to the side. It is not 3 dash. Okay, it is 3. 1 plus z into 1 minus x whole power 3. Okay. What is the answer, guys? Some people has got 15, some people has got 13. Sridhar, you are right. Answer is 15. Sridhar, you are right. Answer is 15. Answer is 15. Okay. Sridhar, very good. Okay. So see this. See this. So this is if the ordinary generating function is z, right? So see, what is a3 minus a0? This is nothing but quotient of x power 3, and this is nothing but quotient of x power 0 in the power series expansion. This is the compact representation. You have to expand it in the power series, then only you are going to see what is the quotient of x power 0 and what is the quotient of x power 3, right? So this is what 1 plus z into 1 minus z power minus 3, right? Now this is what 1 plus z into sigma r equal to 0 to infinity n minus 1 plus r cr x power r, right? Now what is this? This is r plus 2 cr. I can write it as r plus 2 c2. I will write it as r plus 2 c2. R plus 2 c2. Right? Now what do you want? You want quotient. What is a0? A0 is quotient of x power 0. So if I take 1 here, so this is z, right? This is z. So z power r. Okay. Now if I take 1 here and if I put 0 in place of r, then I am going to get 2C2, right? A naught is 2C2. Now, is there any way I can get the quotient of x power 0? This is the only possibility, right? So here if I take it, I will get z power n. So I cannot take it. I can take this one only and I can put a 0 here, c naught, right? Now what is a3? In order to get a3, you can take this one and you can put a 3 here. You can take this one and you can put a 3 here. Then what will it be? It will be 5c2 plus, if I take z, then I have to put 2 here. 5c2 plus 4c2. 5c2 plus 4c2. Now you have to subtract from 5c3 plus 4c2 this 2c2. Then you are going to get answer as 15. Then you are going to get answer as 15. Okay. Cool guys, so that's all about the gate questions of permutations and combinations. We have solved every question of P and C. Next Sunday we are going to do PYQs of regular languages, and all of you please revise regular languages this entire week. We are going to solve every regular language question, but then the length of the class would be at least 8 hours. I don't know if in 8 hours I'll be able to cover all of them. If I'm not able to cover it next Sunday, again on next, every Sunday we have PYQ sessions, okay? Every Sunday, whole day we will have PYQ sessions, okay? Okay guys, so thank you so much. See you all. Okay, Chetran, I am coming, okay?